Okay, the first thing we're going to do is refresh everything that we did from Algebra 2 and pre-calculus. We need to be able to go between exponential and logarithmic functions. For instance, if I have 2 to the third is equal to 8, I can rewrite that as log base 2 of 8 equals 3. The way I remember this is a little circle. 2 to the third gets me 8. Remember that exponential and logarithmic functions are inverses. So on our exponential function, we have 0, 1. So on the inverse, we're going to reflect over the line y equals x, and 0, 1 will go to 1, 0. Another thing in pre-cal you should have learned is how to expand logarithmic functions and condense them as well. For instance, if I have log base 2 of 4x squared y, just as an example. Inside the expression, I see 3 factors, the 4, the x, and the y. So to expand that, we will have three expressions of log. Before I commit to the answer, I notice that log base 2 of 4 can be simplified to 2 because 2 squared is 4. Also, we learn that powers come to the front. So that becomes 2 log base 2 of x plus log base 2 of y. And this would be the expanded form. The reason that we need to have expanded form is because it's easier to take a derivative of simpler expressions rather than having to use the quotient rule. One last thing, remember that when we expand a quotient, we use subtraction because the n will have, it's in the denominator, so we'll have a negative exponent. All right, so for part A, we want to expand it. And I notice I have 3 factors, x cubed, square root of x minus 2, and in the denominator, x plus 1 quantity squared. So when we expand this, I'm going to have 3 expressions of natural log. Notice I changed the form from the radical to the rational exponent. Then we want to look at, I have a typo, because the x plus 1 was in the denominator, it should be a minus. Now we want to look at the powers. The powers are going to come to the front. So this will be, final answer, 3 natural log of x plus 1/2 natural log of x minus 2 minus 2 natural log of x plus 1. All right, for part B, we're going to go in reverse. Let's condense. I see a coefficient, it's going to come to the power. I see a minus, so it's going to be in the denominator. So we have one expression of log, and this will be x to the 1/3 all to the 21st power times, because it's plus, 9x squared divided by 9. The reason it's divided by is because it is negative. Now let's simplify. This will be log base 3 of x to the 7th times x squared, final answer, log base 3 of x to the 9th. Last thing we want you to know before you come to class is, what does a derivative look like for the log? Well, in order to do this, we are going to think about what is the meaning of log base a. Well, that means that y equals log base a of x, so I can rewrite that as a to the y equals x. Now let's take the derivative of both sides. We know from last chapter the derivative of an exponential function is 3 parts. Copy times the derivative of y, which is dy dx using implicit, times the natural log of a. The derivative of x is 1. So when we want to solve for dy dx, we have 1 divided by a to the y natural log of a. But wait a minute. We have a to the y is really just log base pardon me. A to the y is just x times natural log of a. All right. What I know is if I need to take log base 3 of 2x squared, what we just found, I think of it as 3 parts. 1 over the inside times the derivative of the inside times 1 over the natural log of our base. Final answer, 4x, 2x squared, natural log of 3. Let me get you started for the last one. So here we have y is equal to natural log of x. If we rewrite that, that means that x is equal to e to the y. So let's take the derivative of both sides. Derivative of x is 1. Derivative of e to the y is copy it times the derivative of y times natural log of e. Oh, that's 1. So we want to divide to get dy dx by itself. So it's 1 over e to the y, which is dy dx. 1 over e to the y said was e to the y is x. And we will spend more time on that next time.